Chapter 3, we're going to discuss descriptive statistics. And basically what we're looking at with descriptive statistics is how we are going to describe the data that we have obtained through our research study. So an overview of what we're going to look at in Chapter 3 is going to be how are we going to describe the statistics that we acquire through our research. And the one way that we're going to look at it is something called measures of central tendency. And when we look at measures of central tendency, we're going to look at exactly what it says. Central meaning the middle, the average, and tendency meaning how often are those statistics going to fall within the areas that we're going to be looking at. Also, we're going to be looking at measures of variability, how something varies, how those statistics can vary based on our dependent and independent variable. And lastly, what we're going to look at is graphical descriptive statistics, and what we're looking at with graphical is basically how we can put something down in a graph. What type of data are we studying? What type of data are we looking at? Is it categorical, continuous? And that weighs very heavily on what type of graph that we use in order to identify and show the average reader what we have discovered with our research project. So, like I said, descriptive statistics, basically what are we going to use them for? What does it mean? We are using descriptive statistics to help describe our data, help us to put into some form the statistics and the numbers that we have acquired. As the PowerPoint says, it helps us to get to know our data, it helps others to know about our data, and it helps to identify problems within the data. And the first three topics here, we can say this is when we acquire our data. Once again, how are we going to present it? Are we going to present it in a graphical form? Are we going to state it in particular forms of methods that the lay person as well as the educated person is going to understand? And that is something that we kind of see when we see something on the news or New York Times that says drinking coffee is linked to high blood pressure. Basically what they're going to show the average person isn't something that's in depth, and they're really not going to show them what their data is, and they're not going to show them their methods, and they're not going to show them the types of research that they use. They're just going to say, this is what our research came up with. And the average individual is going to read that, and if they don't have knowledge, they're going to say, oh yeah, okay, I believe that. That's something that, I'm going to remember now. I'm going to watch how much coffee I drink because I don't want to end up with high blood pressure. And as I stated in the previous slide, data that is identified in graphs is sometimes easier for individuals, the lay person, to understand because they can visualize a little bit more based on how the numbers have fallen, peaks, lows, and it sometimes is easier for that individual to visualize versus reading something and understanding what they have read. So the first area we're going to look at that is going to help us describe our statistics, or descriptive statistics, is going to be central tendency. And oftentimes, many of us have come out of basic junior high and high school with a basic understanding of what a mean, mode and median is, and basically what we're looking at with that is the typical score that we normally see within a set of data. The mean, the median, the mode. Pretty much all the average. Each one of them has a different way of coming to the average answer, but each one of them have basically kind of the same meaning as far as being average or central or in the middle. So when I started graduate school, no, actually undergraduate school, and took my first statistics class that I had to take, I had heard people use the term mean or median, but I really didn't know how to acquire the mean and median, so don't think this is kind of trivial that I discuss it, because I really just want to make sure I go over it and that there's an understanding of the central tendencies with the mean, median, and the mode. So the mean being the first and the most frequently used measure of central tendency is calculated generally by adding up the total number of scores that are in a sample that we have obtained, and then dividing that number of scores by the total. So in the example on this PowerPoint, it shows us scores of 3, 7, 9, and 6, which adding these up gives us a total of 25. And what we would do would be divide the total 25 by 4, which, as you can see, there are 4 scores or four areas of data that we would divide by. This gives us a total of 6.25, which would be the mean, and that's what we're going to look at as far as, once again, an average of the 4 sets totaled divided by the amount of sets that we actually have. Now, the problem that we're going to see with using the mean is the absolute mean can be influenced by extreme scores. So if we look at the mean of 5, 7, 9, 5, and 8 being 6.8, as we had seen on the previous PowerPoint, and we total those up, divide by 5, we get 6.8. However, if we would throw one kind of crazy score in there, such as 99, so we would have 5, 7, 99, 5, and 8, you can see the difference in that average. The first average we looked at, or the first mean here, with the total of 34 divided by the total number of 5, is 6.8. But then again, if we look at, once again, 5 numbers added up and divided, we get a number of 24.8. So you can see, if we're going to measure things according to the mean, how having an extreme score could really divert or definitely alter what our perception is of the mean or the average or the central, what we're looking at as far as the average within our data or within our scores. So the next area to measure central tendency is the median. And the median, really, when you are trying to calculate a median, which I always kind of think of the median as the median strip, like right down the middle. Median strip in a road is in the middle of the road. You're going to see it's not influenced by extreme scores. It's the middle score after all the scores have been placed in ascending order. So the one thing you're going to remember with the median, remember it's going to be in the middle, like the middle of the road, the median strip. So what you want to do is put all your scores in ascending order. And essentially what that's called is ranking your scores. So once again, if we take the numbers that we looked at for the mean, and we look at them as 5, 7, 9, 5, and 8, how we would calculate them is first thing we would want to do would be rank them. And out of those 5 numbers or scores, we would see that we have 2 5s being the lowest, 5, 5, and then we would see a 7, an 8, and a 9. Locating the middle score, which would be 7, that's going to be what our actual median is. When I look at this, the ranking of these scores, 5, 5, and then I see a 7, and then I see a 9 and an 8. The 7 indicates really the middle, and then you would truly look at this. PowerPoint is actually somewhat incorrect because it should be 5, 5, 7, 8, and then 9, not 9 and then 8. So if I look at 5 scores and I want to look at the very middle or the median of my scores, it's going to be 7. And the last area of measures of central tendency is something called the mode. And the mode is the most frequently occurring score. Typically, once again, used when we have categorical data. So we're going to be able to categorize it, not continuous, because you remember when we talked earlier on in the last chapter, we talked about categorical being nominal and ordinal data, and then we talked about continuous being interval and ratio data. The mode is usually used using categorical data, and what you're going to look at with that is what number are we going to see, whatever our different numbers are in sets of data that we have come up with. Whatever is the most frequently occurring number is what we're going to use for the mode. And so the mode, in my mind, like I kind of think back several years ago, and I think about mode as something as being, what's most fashionable, what you see most frequently, and that would be your mode in the measures of central tendency as well. So once again, look at all your data, and what I kind of like to do is pull all my data together and kind of look at it and say, okay, I like to arrange it in a ranking order. So in this situation, if it were me, I would put 5, 5 next to each other, and if there were some 6s, I would put 6, 6, 6, 6, maybe 2 7s, however many sets of data that were there, I would put them ranking or ascending order. And then I like to look at that data, and then I circle based on how many of each number that I'm seeing. I like to circle and group them and then count them off to find where my mode is actually at. And so something else we're going to look at when we're measuring our data is going to be measures of variability. In our measures of variability, basically what we're going to be looking at is how do things vary? How do our scores vary? And how can we measure that variability? Along with the typical score, it's also very useful to know how the scores actually vary. How, why? The most frequent measures of variability are range, interquartile range, and our standard deviation. And most of us have always, when we read a journal article, we can look at something and say, they talk about the standard deviation, but before I started really studying statistics and really having a good knowledge of statistics, I had absolutely no idea what a standard deviation is. Looking at this, you'll have a little bit better understanding of what it means when you see the standard deviation is a +1 or a -1. You'll have a little bit better understanding. So the first variation that we'll look at is the range. It's pretty simple. Basically, simply we look at the highest score in a sample, and then we minus that highest score from the lowest score. So the range for this sample is 9, being the highest score, and the lowest score in this particular sample is 5. And so all we would do would be subtract 9 minus 5, which would give us 4, which really doesn't say a whole lot. But if we look at something such as the sample of, if we're going to study the sample of minutes to 100% pain relief, say from a headache, and our ranges are 8 and 18, so the highest range being 18 minutes and the lowest range meaning 8 minutes. So we would subtract 8 from 18, which would give us 10 minutes, and that would be our variability. And once again, when we look at our range, we can see a very extreme score of distribution, because if we have something that's really out there, how many minutes till extreme, or I'm sorry, how many minutes till we have relief from a headache, we can have some very extreme scores out there. I mean, some individuals can say 60 minutes or 70 minutes, and some individuals can say 10, which is going to make it at 50 minutes. So the range, although we can see a range between some average scores, but if we have some very extreme scores, it's going to throw that actual number off. Next would be the interquartile range, and once again we're going to look at a range between a few areas, and what this does is give us a range within which the middle 50% of the scores in the sample would fall. So how we calculate it is we find the median, which we just discussed, of the lowest half of the scores. This would give us our first quartile. Then we would find the median. Remember, we talked again about the median being the middle of the highest half of the scores. That would give us the third quartile, and we would subtract the first quartile from the third quartile, which would give us the 50% being in the middle, highest versus the lowest, in order to give us our number. Now our standard deviation, like I said a few slides back, many of our journal articles, many articles that we read, we always read about the standard deviation being +1 or a -1 or +2, -2. Basically what our standard deviation is going to look at is going to be, it's going to measure how much the score varies around our mean. So ideally what we're going to look at initially is going to be trying to find the mean, and then we're going to look at how much the scores that we see or that we're coming up with during our research study are going to vary around that mean. Essentially, it gives us the average amount by which the scores deviate from the mean. And remember, the mean being central, measure of central tendency, so it's going to be in the very middle, and we're going to look at the average amount by which these scores deviate from that average. So looking at some deviations for the mean, some things that may give us a little bit of variability. with the mean, if you subtract the mean from each score, this gives you the deviation that you're going to see, meaning what you're going to see that isn't actually the mean, but how much that score deviates from the mean. So the variance is actually the average deviation or the spread of scores around the mean, which we'll see in a future PowerPoint here. And it's calculated by the individual score minus the mean. So what you would do to figure out the variance would be you would figure out the mean, meaning total all your numbers. In this situation, 5, 7, 9, 5, 8, figuring out the mean. Total of 34 divided by 5 gives us a mean of 6.8. And to actually figure out the variance, you would take 5, the first score, and minus the mean, which is 6.8, and that's going to give us a negative 1.8. So that would be our first deviation from the mean. The second deviation would be the score, which is 7 here. In our average measure of central tendency here, the mean is 6.8. That would give us a 0.2 deviation from the mean, and so on. So if you took 9 minus the mean 6.8, you would get 2.22. So you can see how that would work to calculate the actual variance. So what our standard deviation is going to look like is basically it's going to tell us how tightly all the various examples that we have are clustered around the mean in a set of data, meaning how close those examples of data are to the average. Now, just to try and visualize something, you would think if a lot of the data, the majority of the data that you're acquiring is pretty average and it's going to be around the mean, then that's going to be kind of substantial. You're going to see that in your mind, you're going to think, oh, well, the results of whatever study I'm reading or the results of whatever data I'm assessing, if it's all pretty average around the mean, then that's pretty reliable data. But the further out it goes from the mean, meaning the very center, the less reliable that information is going to be. So on this PowerPoint, stating values are bunched together. If it's a bell-shaped curve and it's steep, the standard deviation is small. And I'll show you that once again on a PowerPoint coming up. When values are spread out, the curve is flat, you have a large standard deviation, meaning what we're looking at is if it's flat, if we have the mean in the very middle and it's flat, that means these numbers are going to be spread out, positive 1, positive 2, positive 3, all the way out, such as on a X and Y numbered line when we look at it. And I'll show you that once again, like I said, it'll make a little more sense once we look at the PowerPoint that's going to be coming up. This will kind of make a little bit more sense for you. It's kind of hard to visualize. Now, looking at what a normal standard deviation would be, about 68% of the scores would lie within one standard deviation of the mean. So if you look at a number line and you have 0 in the middle, meaning that's right down in the middle, that's what your mean would be. And on one side you have a negative 1, and on the other side you have a positive 1, and one side negative 2, other side positive 2, and so on. You look at this, and what you're actually going to see is in a normal standard deviation, about 68% of the scores are going to lie within one standard deviation, whether it's positive or negative, but still the mean is going to be in the middle. So the positive and negative isn't really significant as much as how much of a standard deviation you're going to see. About 95% of the scores that you're going to come up with are going to be within 2 standard deviations of the mean, whether it's a -2 or a +2. About 95% are going to be within 2 standard deviations. And about 99.73% of the observation is going to lie within 3. So ideally, looking at standard deviation of 1, 2, and 3, you are not going to see your scores lying much outside of a positive or a -3 standard deviations from the mean. Set of data basically that's close to the average, while a few examples may be extreme. Way out there, we call those outliers. Every now and then, like if you're collecting data and everything you're coming up with is going to be within 1, 2, 3 measures of the standard deviation, but then maybe you'll see something way out there that's in a -9 of standard deviation. We're not even going to look at that because that's called an outlier, and there's something that's just not average, and there's something that went haywire when we were doing statistics or gathering our data, and we came about that one area that was just way out there. So this is the graph that I was talking about. This isn't something that's indicated in your book, but I think that it shows a kind of a nice visualization as to what I was talking about with the bell-shaped curve, and why, if you have a very good standard deviation, meaning within 1 or 2 points, you can see how it's going to rise, meaning if all your numbers are going to be all around the mean, which is 0, if they're all going to be scattered right around that 0 and 1, we're going to see how connecting basically that data it's going to be going all the way up, and then meaning it's going to be from -3, -2, -1 up to our actual mean of 0, and then once again coming down onto the positive side. Now, on the reverse, if we would look at this and we would say that it isn't a strong normal distribution in the standard deviations are way out there, it would be flat. That bell shape would not be high like that, because there wouldn't be a lot of our data focused and centered around that 0, meaning our mean. It would just be out there. It could be 1 all the way up till 9, 10, whatever, but it would be spread out, and it would be flat, all that data. It wouldn't be clustered around the mean, which means, once again, if it's not within the first -3 or +3, and you have numbers outside of that, it isn't very strong statistics, because it isn't around the average. And so think of it when you're doing research or when you're reading research and you're going to come up with a conclusion. That conclusion should all be pretty much average. That should be something that, if we're going to say that it is definitely a strong correlation to whatever we're studying, that strong correlation should definitely be the average. It should not be abnormal or out of the average. So that's basically what we're looking at with a standard deviation. What's average? What isn't average, and what's out there as an outlier isn't really going to support what our study is actually trying to explore. So in order to calculate the standard deviation from the deviation of scores, meaning we're going to look at what the standard deviation is And then we're going to look at the deviation of the scores that we have obtained through our research. And if we look at this slide, for the particular set of scores that we've been discussing, we have 5, 7, 9, 5, 8, saying those are our scores, and we already determined how to obtain the mean of those scores, meaning we total those, divide them by the total number. So total number would be 34, and dividing them by 5 will bring us to the mean of 6.8. And we already discussed how to find variance, subtracting the mean from the score itself. So if we would subtract 6.8 from 5, we would end up with a negative 1.8. If we would subtract 6.8 from 7, we would have 0.2, and so on. Each of those scores that we have obtained, meaning our variance, we would square those deviations. So if we would square, if we would square negative 1.8, we would end up with 3.24. If we would square 0.2, we would end up with 0.04, and so on. Once you have obtained all of those scores, remember we're going back to that initial set of scores, 5, 7, 9, 5, 8, and we have obtained our variance. We've squared them to see the deviation, and then what we would do would be find the mean of the squared deviation. So we would total the 3.24, 0.04, 4.84, 3.24, 1.44, which would equal 12.8. Once again, we would divide that by the total number of scores that we have, which is 5. We would end up with 2.58. This would be the total variance of the deviations from the mean. Take that variance, and what you would end up doing is taking the square root of that total variance, which is our total variance of all the deviations and all the variances, 2.58. We would square that, and we would end up with an overall standard deviation of 1.6. So going back to the beginning of the chapter, we talked about another way to describe our statistics or descriptive analysis, and that would be in a graphical form. And basically what we're looking at with graphical descriptive is describing the data by showing them in graphs. And most commonly the techniques that we see are bar graph, line graphs, frequency histograms, and box plots. First, what we're going to look at are bar graphs. And the height of the bar graph often represents some group or statistic. Often it's the mean that we're looking at. If you look at bar graphs, we notice that they're not connected. And so as soon as you see something that two separate groups that are not connected, that's going to lead you right off the bat to think of something that is categorical and not continuous. So we're going to be looking for categorical data versus continuous data. And if you look at these, we have in the first graph, we have a simple bar graph, and then if we look at the second, we have a clustered bar graph. And what we're looking at are stroke patients versus heart attack patients. And you're just looking basically at the mean, the number of patients that you're going to see in each group, and it's pretty easy to simulate. We're looking at stroke patients on the x-axis, and you're looking at the mean of those individuals' coping scores on the y-axis. And so just looking at this simple bar graph, you're going to see that obviously heart attack patients have a much higher rate. Looks to be about 25,000 more, or 25,000 of them have better coping skills than the stroke patients who are 20,000. It's pretty easy to simulate, to understand. If you look at the clustered bar graph, what we're looking at here are a couple different issues. We're looking definitely at two different groups. Remember, we're not looking at them being continuous, they're categorical. We're looking at stroke patients, heart attack patients. We're looking at several different issues within each group. So that's a clustered bar graph. So you're looking at depicted by the color of the graph, the coping skills being darker blue, what their stress is, and their walking physical well-being in light blue. So you look at stress patients, and you look at the heart attack patients, and their coping skills once again are much higher, as well as their stress skills, and their overall well-being is that they're not nearly as healthy, obviously, as the heart attack patients. So you can see there at probably about 2.5% versus the stroke patients whose physical well-being looks to be about 5%. So those are actually pretty easy for just the average person to understand. So another way of simulating our information and our statistics that we have gathered is through line graphs, and sort of similar to bar graphs. The means represented at the end points of the lines. So just looking at the indicators on the right-hand side, the well-being is a straight line. That's well-being at 3 months, well-being at 6 months is the dotted line, well-being at discharge is the staggered line. So if you kind of look, just looking at stroke patients, and we're looking at both of them as far as well-being at 6 months and well-being at 3 months, the stroke patients look to be right about at the same point. And then when we come down to the very end, the mean heart attack patients, we're looking at starting at about 2, and we're increasing at about 5. So just kind of looking at those, once again, these are pretty easy to follow. Just know, once again, with your line graphs, you generally are not going to be looking at continuous. You're going to be looking at categorical data. And then another area that we're going to look at are histograms. And histograms are going to illustrate the dispersion of the scores in the sample. The height of the bars represent the frequency of particular scores in the sample. So just looking at the same topic that we were just looking at as far as stroke and heart attack patients, once again, you can look at a histogram and see how they're connected. Just see how all these graphs on the group, as far as bin with 1, some of them are connected, and then bin with over 5, you can see how they're all connected. So when you're going to be looking at a histogram, you are going to be the first thing you're going to think of is this is going to be continuous data because it's connected. All the scores that we have are connected scores. So another way to identify the data that we have discovered or the data that we have obtained through our research is something called box plots, which aren't normally, you don't see them used quite as often, and sometimes they take a little bit longer to kind of identify what you're going to be looking at. But basically what you're going to look at with box plots are, they're going to be looking at extreme scores. And if you looked at group 1, which is the coping score of the stroke patients, you can look at the average is around 20,000, meaning in the very middle, that box itself, but it also identifies the outliers or the extreme scores that we talked about. The straight line that goes horizontal at 0 and the straight line at 40. And those are our extreme scores. Those are our outliers that we're going to see. And if you look at the actual box, it's probably at about 20, and the mean indicated with the thick line in the middle of the box at maybe about 25. So once again, what you're going to be looking at with box plots is going to show you the average, but it's also going to show you those extreme scores. In the second box, you're going to look and see, just looking at extreme scores, I look at a 0 and I look at 40 being the horizontal lines that we see, and then in the very middle we see it at about 20, and the mean at about, once again, maybe 21 or 22, and that's on our stroke patients. And if we look at the heart attack patients, we see some outliers at maybe 21 or 22, and maybe it's about like, I don't know, 31, 32, with the average or the mean being at 30. And the probably I would have to just, looking at this and trying to identify, I would say that the average scores that we're looking at are between 25 and 30, and probably the mean looks to be at about 28. So just a summary of what we looked at in Chapter 3. We identified the measures of central tendency, the measures of variability, and how we're going to describe our data in a graphical form.